Hello students, welcome to today's lesson on congruence. Here's the roadmap for our lesson today. First, we'll dive into the concept of congruence. We'll then explore how to identify when two triangles are congruent, even with limited information. Let's get started. So what is congruence? Congruence in geometry means that two shapes are identical in shape and size. This means their corresponding sides and angles are equal. Let's apply this idea to triangles. When we say two triangles are congruent, we mean that their corresponding sides are equal in length and their corresponding angles are equal in measure. They may be flipped, moved, or rotated, but if we reposition them, they should overlay each other perfectly. Knowing that two triangles are congruent allows us to make many inferences about their properties. For example, if we know that two triangles are congruent and we have information about one of them, we can directly apply this information to the other triangle. This can simplify solving problems significantly. Now let's turn to identifying congruent triangles. To determine if two triangles are congruent, we use specific rules based on their sides and angles. Let's explore these. First, the side-side-side criterion. This says that if all three sides of one triangle are exactly equal to all three sides of another triangle, then the two triangles are congruent. Imagine we have two triangles, triangle ABC and triangle DEF. If AB equals DE, and BC equals EF, and CA equals FD, then triangle ABC is congruent to triangle DEF. Next, we have the side-angle-side criterion. This says that if two sides and the angle between them in one triangle are equal to two sides and the angle between them in another triangle, the triangles are congruent. Consider two triangles, triangle PQR and triangle STU. If PQ equals ST and PR equals SU and angle QPR equals angle TSU, then triangle PQR is congruent to triangle STU. Third, we have the angle-side-angle criterion. This says that if two angles and the side between them in one triangle are equal to two angles and the side between them in another triangle, the triangles are congruent. For example, take two triangles, triangle XYZ and triangle LMN. If angle YXZ equals angle NLM and angle YZX equals angle MNL and side XZ equals side NL, then triangle XYZ is congruent to triangle LMN. Why is this important? Well, think about designing a piece of machinery. Engineers need to ensure that different components fit perfectly together. If two triangular pieces are meant to be identical in shape and size, knowing their properties can save a lot of time and effort in the design and manufacturing process. In mathematics, this idea helps us to infer several facts about one triangle if we know enough about its congruent twin. In today's lesson, we delved into the concept of congruence within two-dimensional shapes, focusing particularly on triangles. We began by understanding what congruence means in geometry, two shapes that are identical in shape and size, with corresponding sides and angles being equal. We then explored why congruence is important, noting that it allows us to make inferences about shapes based on their properties, simplifying problem solving. We identified congruent triangles using three main criteria. The side-side-side criterion, which states that all three sides of one triangle are equal to all three sides of another triangle. Second, the side-angle-side criterion, which states that two sides and the angle between them in one triangle are equal to the corresponding parts in another triangle. And finally, the angle-side-angle criterion, which states that two angles and the side between them in one triangle are equal to the corresponding parts in another triangle. By understanding and applying these congruence criteria, we can recognize patterns and simplify complex problems.